All right, next is something a little bit different, okay? We're going to be looking at example 4, I suppose. Oh, my word. All right, you know what? Let's just start over. Cut the video, cut the video. No, just kidding. Let's do example 4. All right. Find an equation. Remember, there are multiple ways to write an equation. So let's say find an equation of the tangent line of f of x is equal to 1 divided by the cubed root of x at x equals 1. Now, the book has a formula to find the equation of a tangent line. Please never look at that formula. You can if you want. If you really love formulas, go for it. But it's going to be much better for you conceptually if you just kind of understand what's going on. So we need to find an equation of a tangent line. So what do we need? What do we need to find an equation of the tangent line? Well, we need the slope of the tangent line, and we need a point. Once we find the slope of the tangent line and a point, well, we have point slope form. We've done that before. So we really just need slope of the tangent line. Well, how do we find slope? Slope is derivative. The slope of a function is the slope of the tangent line. So it's all connected. So let's just comment on that right here. Right? Slope of tangent line is the same as the slope of the function, which is the same as the derivative. So it's all connected. Slope of tangent line, slope of function, derivative. So if we need the slope, we need to find the derivative. All right. Anytime you're trying to find slope, you're probably going to have to take the derivative. Okay. So this is not in the form that we want, right? The form that we want is we want this to be in the form x to the r. And this has two problems with it. It's in the denominator and it has a radical. So we're going to have to use both of those rules that we talked about earlier and rewrite this function. So first off, let's just look at the denominator. X to the third root of x. Remember, if you have a root, that's a fractional exponent. So x to the 1/3 is the same as the cubed root of x. And then if it's in the denominator, that's the same as a negative exponent. Negative exponent means reciprocal. So this is actually x to the negative 1/3 is what our function is. These two things right here are the same. And now that we have written it this way, we can find the derivative, no problem. We'll use the power rule. So what we have is that f prime of x, the slope, the derivative, bring down the exponent, negative 1/3. Our new exponent is the old exponent, minus 1. And you can simplify that out. I won't do it all over again, but negative 1/3 minus 1 is negative 4/3. So that's our slope formula. This is our derivative right here. But remember, this is the derivative for any x. Now, we don't want any x, right? We specifically want the derivative. We specifically want the slope when x is equal to 1. All right, so we're going to go over to the new page and say, well, I really just want the slope when x is equal to 1. So what was our formula? Negative 1/3 x to the negative 4/3. I'm going to write that down. Remember, it was negative 1/3 x to the negative 4/3. And we are just plugging in x is equal to 1. We're going to get negative 1/3. Oh, and here, right, here is where it's a little weird to plug in x is equal to 1 in this form. Let's rewrite it. You don't have to rewrite it, but let's rewrite it a little bit on the right here. Remember, the only thing that has the negative exponent is the x. We have the negative 1/3. That behaves normally. The x has a negative exponent, so it goes in the denominator. x to the positive 4/3. And if you wanted to, you could actually even rewrite it again, although you don't have to. You'd rewrite this as negative 1/3, the cubed root of x to the 4th. So whichever way is easiest for you to do right here. But the fact of the matter is that we're plugging in 1 for x. So we're going to have negative 1/3 times cubed root. That's the cubed root of 1 to the 4th. Well, 1 to the 4th is just 1. The cubed root of 1 is also 1. 3 times 1 is 3. So it really just becomes negative 1/3. And you can use a calculator to help you get here as well. You don't have to do it all by hand. So remember what we needed here. We needed the slope and we needed a point. Well, we found the slope, okay? We have the slope for our tangent line. Right, this right here is slope. Oh, I wanted a different color. I didn't hit it. This right here is the slope of the tangent line. Now all we need is a point. Well, we already know the x-coordinate, right? We know x is equal to 1. We just need to find what y is equal to. Well, luckily for us, we have a relationship, right? We know that f of x is equal to, what was f of x equal to actually? F of x was equal to x to the negative 1/3, or you could use it in this form, 1 over the cubed root of x. Well, f of x, right, we can think about that as y is equal to 1 over the cubed root of x. So when x is equal to 1, what is y equal to? Well, when x is equal to 1, y is going to be 1 over the cubed root of 1, which is just 1. So we have the slope. We have, goodness, my clicking is really not on today. We have the slope now. We have the point now. We can use point slope form. All right, so the slope's negative 1/3. Let's write that down. And the point is x comma y. X we said was 1. Y we said was also 1. Let's use point slope form to get the equation of the tangent line. Y minus the y coordinate is equal to the slope times x minus the x coordinate. And this is the answer. This is our equation of the tangent line. And because we love checking our answers and we love seeing things graphically, if you wanted to, you could check your answer like so, using a website such as Desmos. That's the next video. Interesting. Let me change windows real quick. All right, that's we're having a bit of an issue today. Technical difficulties over here. This will work. All right. So let's check our answer. So here's the equation of the tangent line. Negative 1/3 times x minus 1 plus 1. And hopefully this is tangent to the graph that we wanted at the given point, which was y is equal to 1 divided by the cubed root of x, which is the same as x to the 1/3. And oh, I'm so relieved. Look at that. That's a beautiful tangent line right there, no? That's as tangent liney as they get. So we wanted it to be tangent at this point. So we know we did good. All right, so that's what's going on in this video. I thought this video would be super short, but because it was only one problem, but it was 10 minutes. Let me know if you have any questions on this stuff though.